Okay, next problem up. I'd like to look at problem number 36. And I'm looking at the cosine. I know this looks like a big mess. Well, it depends on who you ask. So, I'm looking at a cosine equaling 1/2. The reference angle would be, in this case, pi over 3. 2. We know that the cosine of any angle, no matter what that is positive in quadrants 1 and 4. And we know in quadrant 1 it's pi over 3, quadrant 4 pi over 3. But since this is not my traditional angle, I'm going to say it's pi over 3 plus 2 pi k, so that let the algebra take care of the shifting and the phase shift and the compression or the stretching. And 5 pi over 3 plus 2 pi k. Again, this is really coming out of this, and this is coming out of this. I just add 2 pi k, and this is the first place in which the angle comes in. So, the angle, no matter what that is, doesn't come up until the very last step if we follow the same process. And now this is no longer trig, this is just algebra. If I clear the fractions, LCD is 12, this is 4 theta minus 3 pi. You could do this any way you like. I teach my students how to do problems this way. 4 theta will equal 7 pi. It adds an extra step, but better be safe than sorry. Multiply by a fourth or divide by 4, however you want to see that. There would be the first solution. And if I do the same right here, clear the fractions, 4 theta minus 3 pi will equal 4 times 20 pi plus 24 pi k. Divide by 4. After you move this, that will be 23 pi divided by 4 plus 6 pi k. And if I let k equal 0, remember I want the solution between 0 and 2 pi. Theta will be 7 pi over 4. And this will give 23 pi over 4. That's definitely bigger than 2 pi. So that's the only solution I get, because if I add 6 pi to any solution that I have, it's going to be bigger than 2 pi. And that's pretty much what this big, messy problem looked like. Now I'd like to look at different problems. I'd like to look at the next set of problems, and those problems read, solve each equation. Alright, they want us to solve this. And they want us to find the general solution, plus list 6 solutions. Alright, so if we want to work this out, 1, the reference angle is pi over 4. Secondly, where does tan of theta equal positive? Well, that happens in quadrant 1 or 3, but we know the drill. If it's a tan, we simply take one of the angles. We don't need both. We could use both. But for tan and cotan, we know that this angle equals any one of those plus pi k, and that pretty much finds me the general solution. There it is. That's what they want. And then they want us to list 6 solutions. Let k equal 0, I get theta to be pi over 4. Let k equal 1, I'll get theta to be pi plus, that's 3 pi over 4, 5 pi over 4. And you notice this is right there. K equal 2. Theta will equal, well, from 1 pi over 4 to 5 pi, add another 4, that's 4 pi over 9. K equal 3. I will get, if you put a 3 there, 3 pi plus pi over 4. Add 4, add 4, add another 4. And you could just do that until you list all 6. I'm going to find a couple of negative values just for the heck of it. If I put a negative 1 right there, it'll be pi over 4 minus pi. That is negative 3 pi over 4. And what is that? 1, 2, 3, 4, 5, maybe one more. K equal negative 2, and I'll get theta to equal negative 7 pi over 4. If you want to find all of these to be positive, you can out of mind. So if you just want to say, well, look, once I do this, from pi over 4 to 5 pi, add another 5, that's 9, 13, 17, you could do that. That's not a problem. I want to do another problem like this. and I'm picking number 44. Here they did compress or stretch the angle, not that it matters. Well, here, no need to find the reference angle because this is a special case. That is, sine of theta equal -1 in one location only. That's at 3 pi over 2. Since they want the general form, I'm going to add 2 pi k. Normally, I have two solutions for sine and cosine, but since this is a special case, it only happened in one place. This is the general solution, and this is, again, the first place where that angle comes in, multiplied by a half. And there are the infinite amount of solutions, or the general solutions. You want to find 6 solutions, not a problem. Let k equal 0. Theta would be 3 pi over 4. Of course, you don't have to write that. Let k equal 1. What is 3 pi over 4 plus pi? 4, that's 7 pi over 4. And once you figure out what you've done, you went from 3 pi over 4 to 5 pi over to 7 pi over 4. Add another 4. Add another 4. Add another 4. And add another 4. You could say those are my 6 solutions. You could say, you know what, I want k to be -1. Just for the heck of it. You say, okay, well, theta equal 3 pi over 4 minus pi. That is over 4 negative pi over 4. That could count. And you could find few negatives if you wish. It's up to you. Whatever makes you happy. I'd like to look at a few more problems from the next batch of... The next problem I'd like to look at would be problem number 62, and here directions vary slightly. It's the same idea over and over. This says solve each equation between 0 and 2 pi. Well, let's see how this works. It's true this is a trig equation, but it is a polynomial or quadratic in nature. We know a lot about quadratics. We know how to factor those, right? We spend a very long time on this in algebra. So if I say this is +1 and a -1, there it is. And we know if you multiply two terms and get a 0, cosine, not cosine squared. You guys, be careful. So I know if you multiply two terms and get a 0, that means either twice the cosine of theta minus 1 equals 0, or the cosine of theta plus 1 equals 0. Well, this says the cosine of theta equals 1/2, or the cosine of theta equals -1. Now, if this angle is untouched, that is, you didn't really compress or stretch, we know that this has two solutions. And this happens to be a special case. So we know the reference angle right here, well, we did this over and over. The reference angle would be pi over 3, and cosine is positive in quadrant 1 and 4. In quadrant 1, that angle will be pi over 3, and in quadrant 4, pi over 3. And we know that cosine is, oh, that's an ugly circle. We want that to look pretty. Something like this. We know that cosine is -1 at one place only, so we tag that on. And the reason here, I don't need 2 pi k. They're not asking for 6 solutions. They just want the values in which those unstretched or uncompressed equal a value. So I know that there are 2 for each trig function unless it's a special case. I want to tackle another problem. I'm hoping to do 2. I'm really greedy today. I'm going to do this one and hopefully one more within the 6 minutes. Well, trying to figure out where does this equal 0. Well, 0 is a nice number. So we know this is an odd function that's negative. The sine of theta equals 0. So I'm trying to figure out where do you take sine and cosine, add them together and get that to be 0. Guessing is very hard. If I manipulate the problem just a bit and divide by cosine both of those, right? Not your traditional techniques. I'll get the tan of theta equal -1. Guess what? I know exactly where that happens. 1, the reference angle will be pi over 4. 2, where does the tan of an angle equal negative? that is in quadrant 2 and in quadrant 4. And what would pi over 4 be in the second quadrant? 3 pi over 4. And what would that be in the fourth quadrant? 7 pi over 4. And since this angle is not compressed or stretched, that would be my answers. That's it. I know there are two answers to every trig function being positive or negative, unless it's on the x-axis or the y-axis. That's a special case. And it looks like I'm going to be able to do one, maybe even two. Like I said, I'm really good. The next problem I chose is number 78. I'm trying to figure out where does cosine squared of an angle equal this big mess. Well, if I clear the parentheses, I notice this could be a quadratic equation. One catch: they're not matching. That is, this is not the square of this. Well, I know what cosine squared equal because I know the most famous identity of them all. Pythagorean says cosine squared of an angle plus sine squared of an angle equals 1, which means cosine squared equals 1 minus sine squared of an angle. If I get everything on one side 0 on the other side, I'll be looking at sine squared of theta plus 4 the sine of theta plus 3 equals 0. That would mean I could factor this. The sine of theta, and a plus 3 and a plus 1. This says sine of theta plus 3 equals 0, which means sine of theta equals negative 3. That's impossible. Or sine of theta plus 1 equals 0. That means sine of theta equals negative 1. And I know this happens only in one place. This is a special case again. Every now and then, things do happen that way. And if I want to know where does sine of theta equal negative 1, sine of theta equal negative 1 only in one place. That's when theta equals 3 pi over 2. And since they're restricting the angle to be between 0 and 2 pi, this would be my only solution. It looks like I could fit maybe one more. I'm going to keep my fingers crossed and try. If not, I'll have to cut it at the end. Okay, I'm able to do one more, so I went back to 47 through 58. It says use a calculator, kind of like what we did in section K back in the days, and find the angle between 0 and 2 pi. Now, to use the calculator, I'd suggest you stick with degrees. You could convert to radians, but it's hard to see a bit. I'm trying to figure out where does the sine of theta equal negative 0.2. Well, this is not a standard angle. I'm going to proceed identical to what I did. Basically, I'm asking where does the sine of theta equal 0.2. That would be when theta equal the arc sine of 0.2 like we did in section K. Remember, section K was the section I added to the book. If we take 0.2 and take the inverse sine, 11.54 degrees. 2. Where is my sine of theta negative? That would happen to be in quadrant 3 and 4. So if this right here is 11.54 degrees, and this right here is 11.54 degrees, let me enlarge that just a bit. What do you think this angle is? Wouldn't here theta equal 180 degrees plus 11.54 degrees? And here it will be 360 degrees minus 11.54 degrees. And my solution would be, since the angle is not stretched or compressed, I'll take 180 plus 11.54. Oops. I'll take 180 plus 11.54, and that would be 191.54 degrees, or I would take 360 minus 11.54, and that would be 348.46 degrees, and that would do it. And there's the rest of the homework, and you could work